Today we will be looking at enriched media. What is a culture medium? A culture medium is generally a solid, liquid, or semi-solid that is designed to support microorganism growth. There are different mediums available to grow different cell types. What is an enriched media versus a selective medium? An enriched media contains added nutrients to the standard media that allows for the growth of a wider variety of organisms in the specimen and fastidious microorganism growth. On the other hand, a selective media is used for the growth of only specific organisms that you select for. This can be achieved by using things like antibiotics that allows only resistant microorganisms to grow on your medium, and it will inhibit the growth of other microorganisms. What are enriched media used for? Enriched media can be used for the growth of fastidious organisms. Fastidious organisms are those that cannot create the nutrients themselves, but the nutrient is still needed in the medium in order to culture the microorganism. These nutrients would then have to be added to the enriched media to allow for the growth of the fastidious organism. Enriched media allow for the culturing of organisms that may not grow using a normal medium. What are enriched media made of? Enriched media are generally made using the common medium, such as a common agar plate, and then adding your special nutrient to this medium. The standard ingredients of a normal agar plate would be its polysaccharide agarose gel and its normal nutrients. To make it an enriched media, there is the addition of a special nutrient that allows for the growth of these more fastidious organisms. Commonly, the enriched media nutrient is blood or serum, which contains growth factors, vitamins, and numerous essential nutrients required for the growth of fastidious organisms. One of the most common enriched media used is the chocolate agar. A chocolate agar contains added red blood cells that have been heated, and the hemoglobin from these cells supplements the basic ingredients found in an agar plate. The added nutrients provide the correct factors needed for the culturing of many pathogenic organisms, such as the meningitis bacteria and the gram-negative bacteria that is responsible for the sexually transmitted disease gonorrhea. What makes a good enriched media? The final properties an enriched media should contain are the presence of the standard medium and its respective ingredients, along with the addition of the nutrient of interest you need to grow the fastidious bacteria species you are interested in. It is important that you have the correct basal ingredients along with the correct special nutrient you need. You must ensure the proper steps are carried out when adding the special nutrient, such as heating the red blood cells prior to adding them to the chocolate agar to achieve your desired results. What makes a good enriched media? The final properties an enriched media should contain are the presence of the standard medium and its respective ingredients, such as those found in a standard agar plate, and along with that, you want the addition of the nutrient of interest that you need to grow the fastidious microorganism species you are interested in. It is important that you have the correct basal ingredients along with the correct special nutrient that you add to your enriched media. You must ensure the proper steps are carried out when preparing your enriched media and adding the special nutrient. For example, we previously talked about the chocolate agar and how we must heat the red blood cells prior to adding them to lyse them, as this will allow for the addition of hemoglobin to the medium, and this is how you will achieve your desired results. Another commonly used enriched media is the blood agar, and its preparation slightly differs from the chocolate agar. We will now look at what makes a blood agar good. In the blood agar, 5 to 10% nutritious sheep blood is added in solution, and then this solution is added to the standard agar plate. It gives the agar plate a bright red appearance, which is where the plate gets its name from. There is no heating required to lyse the blood cells. If prepared correctly, you should be able to observe the hemolytic properties of various cultured bacteria as seen in the picture below.